Hi, this is Samasam, Assistant Professor, SNS College of Technology. Uh, in the previous classes, we have discussed about the various type of sensors along with the touch sensors, and it is classified into two types. One is resistive and another one is. Now we are going to discuss about the sensors which are used for conducting an electricities. Now we are going to discuss about the resistive touch sensors. When I say that resistive touch sensors, these are based upon depending upon the resistance to an electrical disturbance. So as I said that this is an sensors where the resistance has been takes place into considerations. When you say that the resistive tensor is one of the type of sensors that function based on change in an electrical resistance. As I said that earlier, it is one of the most common type of touch sensor technologies and widely used in the variety of equipment and different type of things, these consist of flexible top layer and rigid bottom layer, both connected with an conductive material. When the pressure is applied, the two layers touch, change in resistance to determine the touch location. While cost effective, versatile and durable, and they can be responsive and may offer residual display clarity compared to the capacitive sensors. So as I said that the operation of resistive touch sensors depends upon the electrical resistance. When the pressure is applied to the surface of the sensors, it causes change in resistance, which is then detected and translated into a specific input. This type of sensor is particularly effective because it can detect touch from almost any kind of object, but in a stylus, gloves, hand, or a bare finger. So this is how the basic structure of resistive sensors and how it has been working has been. As I said, there is a flexible top layer and there is a rigid bottom layer. Both are coated with a conductive material, typically indium oxide (ITO), and are separated as small insulating spaces. So the flexible top layer is usually made up of flexible materials like a polyester or polythene, which are able to deform when the pressure is applied. This layer is transparent and coated with a thin layer of conductive materials. Rigid bottom layer is often made of glass or similar rigid materials like the top of the layer. It is also coated with a conductive material. When the when the user applies a pressure to the top layer, it deforms. And comes into contact with the bottom layer. This creates a circuit and change in the resistance is measured. These measurements are then used to determine the precise location of the touch. So as I said that the main advantages of resistors are cost effective and versatile and durability, and it is less complex and low power consumption are the major important advantages. Despite these advantages, it is more important to note that resistive sensors are not without their drawbacks, right? So compared to a capacitive sensor, additionally, the use of two layers can reduce the display clarity, and also it cannot be used as a multi-touch sensors. There is a low clarity, less responsive, wear and tear is are the lot of various applications. And when you go for an applications of resistive touch sensors, there can be used point of sale systems, industrial control panels, medical devices, apart from that musical instruments, touch pads, older musical players, game controls, and office equipments where they are used. But in conclusion, the music in the resistant touch sensors are a fundamental part of the touching sensing technologies landscaping, despite facing the competition from more advanced technologies like capacitive touch sensors. They still hold a significant place in numerous applications due to their cost effectiveness, versatility, and also based on their durability, like any technologies. They have their strength, weakness, and their use of the most effective when they are tolerated to suit the specific needs of an application. As and technology continue to advance, it will be interesting to see how the sensors evolve to meet the ever-changing needs of the users and industries. These are the reference I have taken for today's video. Up to that, bye-bye. Thank you. Signing off from Samasam, Assistant Professor, SNS College of Technology. We'll meet you in the next video. Thank you.